Welcome to the Evidence Room. I'm your lead detective, and you are stepping into a highly restricted, high-stakes explainer today. We are officially opening Case File 9709, and we're specifically targeting a notorious sector of Cambridge AS and A-level mathematics. Our primary suspects for today, quadratics and the discriminant. Now, as an exam criminologist, my job isn't just to teach you math. My job is to treat these Cambridge past papers like intricate crime scenes. They are literally littered with hidden forensic clues, command word traps, and analytical pitfalls that drain away your marks. So we need to gather the facts, secure the perimeter, and completely decode the exact, uncompromising expectations of the Cambridge examiners. If you've been bleeding marks on what you thought were straightforward algebra questions, you're in the right place. Grab your notepad, because we're going deep into the examiner's psyche.
Okay, let's dive into this. I want you to look incredibly closely at the quote right here on the board. This is not just some offhand comment from a teacher. This is a direct, verified piece of intelligence pulled straight from the official Cambridge Principal Examiner report. They state in black and white that quadratics, discriminant and nature of roots is one of the most misunderstood areas in mathematics. Now we have to ask ourselves, why? How is something so foundational causing so much devastation across global cohorts? Well, it's because candidates constantly misidentify the motive at the crime scene. They see a quadratic equation, and what do? They panic and they immediately rush to solve for x, without stopping to actually analyze the nature of the roots. That vital b squared minus 4ac piece of the quadratic formula isn't just a random calculation. It is essentially the unique DNA profile of that specific equation. It tells you exactly how many roots exist. It tells you whether a line elegantly intersects a curve, if it perfectly grazes it as a tangent, or if it misses the curve entirely floating out in space. But year after year, brilliant students bleed massive marks here because they lack the forensic precision required to actually interpret that DNA. They leave massive vulnerabilities in their working, and the examiners penalize them heavily for it. We are going to lock down those vulnerabilities right now. Here is your official case file blueprint to decode the syllabus and stop unnecessary mark loss today. We'll start with number 1, the crime scene. Then number 2, procedural framework. Number 3, interrogating evidence. Number 4, top examiner warnings. And finally, number 5, case closed.
Section 1, the crime scene. Let's establish exactly what the examiners are looking for.
Now, what's really fascinating about this breakdown is how it reveals the exact psychological profile of a top-tier 100 percentiles candidate. The examiners are specifically targeting 3 highly distinct cognitive domains. Let's break them down. First up, we have knowledge and understanding. This is your raw physical evidence. Do you actually know the discriminant formula? Do you know that greater than 0 means 2 distinct real roots, exactly equal to 0 means 1 repeated root, and less than 0 means absolutely no real roots? That's just the baseline. But here's where we need to talk about 2 archetypal rookie detectives we see in the field all the time, Agent Alex and Agent Sam. Now, Agent Alex is a procedural detective who is fantastic at gathering this raw physical evidence. Alex can recite every single textbook definition perfectly, but Alex completely fails to build a coherent case motive because the syllabus demands the second domain, application to unfamiliar contexts. When the examiner aggressively disguises a quadratic inside a really complex coordinate geometry problem, Agent Alex just freezes up. The facts are there, but the application is missing. Then we have Agent Sam. Sam is a fast-acting detective. Sam sees that disguised quadratic and jumps immediately to a conclusion, totally skipping the vital third domain, critical analysis. Sam completely ignores the command word constraints of the question and makes wild logical leaps without leaving a solid trail of evidence. So to get the absolute maximum marks on these high-tariff questions, you must seamlessly integrate all 3 of these domains. You have to possess the knowledge, bravely apply it to the unknown, and then critically analyze your findings to prove your case.
Let's look at the critical difference between how those rookies and our seasoned veterans handle the evidence. On one side, we have superficial breadth. This is a shallow, highly descriptive statement. Honestly, it's exactly like finding a blurry fingerprint at the crime scene but never bothering to run it through the database. A superficial student might write out the quadratic formula and just plug in the numbers, sort of hoping the examiner will miraculously figure out what they mean and award the marks out of pity. But the principal examiner reports explicitly highlight that top band marks, the ones that secure your A-star, go to candidates who consistently exhibit cross-topic conceptual depth. So what does that actually mean in the exam room? It means proving that you understand the discriminant is not just some isolated abstract algebra trick you learned in Chapter 1. It is a master key that connects deeply to geometry, to calculus, to tangents, and to normal lines. When you explicitly state on your paper that you are setting the discriminant to exactly 0 specifically because the line is a tangent and therefore only intersects the curve at one single solitary point, you are providing that cross-topic conceptual depth. You are proving to the judge, which is the examiner, that you understand the entire interconnected theoretical architecture of the mathematics. A superficial answer is a mismatched fingerprint. A cross-topic conceptual argument is a locked-in, undeniable, airtight conviction.
Section 2. Procedural Framework. Let's transition into the structural blueprint required to process this data.
Let's move to the evidence board and see how this builds into a flawless methodology. Here is a strict 5-step procedural blueprint for systematically processing any quadratic question without dropping a single mark. Step 1. Deconstruct the question. You must isolate the official command words. Are they asking you to solve, to show that, or to find the set of values? Each one of those commands requires a totally different level of forensic stringency. Step 2. Extract data. You need to pull the precise coefficients, your A, your B, and your C values, out of the disguised equation, and you have to watch out for sneaky negative signs. Step 3. Select the analytical framework. Are we looking for intersections? Are we looking for tangents? This entirely dictates whether your discriminant is set to be greater than, equal to, or less than 0. Step 4. Execute with clear notation. Listen to me, this is where Agent Sam usually fails spectacularly. You must write out the inequality perfectly, line by line, maintaining absolute algebraic discipline, no skipping steps. And finally, Step 5. Present with correct terminology. You finalize your answer not just as a random floating number, but in the exact correct format, whether that's a beautifully formatted inequality range or exact coordinates. If you force yourself to follow this standardized sequence every single time, you completely eliminate the chaotic, unforced errors that constantly plague lower band candidates.
This brings us to the absolute most critical defensive strategy in your entire arsenal, the method mark. I need you to understand that marks in Cambridge math are heavily awarded for the mathematical process and your structural working, not just for getting the final outcome right. Think of method marks as the bright, undeniable forensic trail of evidence you purposely leave behind for the examiner to find. Let's say you're under immense pressure, the clock is ticking, and you make a tiny, silly arithmetic error in Step 4. But because your Step 3 selection and your Step 5 presentation logic are structurally brilliant, the examiner can and will still award you the vast majority of the marks. They are rewarding your analytical intent. But if you try to act tough and do all the heavy math in your head, or scribble it on a scrap piece of paper that gets thrown away, and you simply write down the wrong final answer on the line, your case is completely thrown out of court. 0 marks. 0. Method marks are your ultimate insurance policy. They are the breadcrumbs that prove your logical intent, and they are absolutely crucial for salvaging your grade when exam room anxiety causes a minor miscalculation. You have to leave the trail.
Section 3. Interrogating evidence. It's time to shift our investigation and evaluate the core trends.
Higher-order assessment objectives in this syllabus scale up over time. They demand significantly more than just basic data tracking. You always start at the descriptive level. This is simply identifying that a quadratic equation naturally exists somewhere hidden in the problem. Okay, fine. Then you move up to the analytical level, extracting those specific coefficients and correctly plugging them into your b squared minus 4ac formula without messing up the algebra. But to reach the elite top tier, you must ascend to the evaluative level. Evaluative thinking requires you to actively question assumptions and rigorously justify your final decisions. It is simply not enough to blindly calculate that the discriminant is negative and stop there. You must evaluate what that result actually means in the specific real-world context of the question. For example, you need to clearly conclude that because the discriminant is less than 0, the vehicle's trajectory, which is modeled by the line, will literally never intersect the physical boundary, which is modeled by the curve. That is the exact level of justified contextual recommendation the examiners are desperate to see from you.
And this brilliantly illustrates exactly how top-scoring candidates construct an unassailable comparative analysis. When interrogating a complex problem, particularly those heavy tariff ones that ask you to compare two different mathematical models or roots, you need to deploy this evaluative thinking matrix. First, you compare by aggressively identifying both similarities and differences. Don't just give half the picture. Second, you connect everything using logical connectives in your final presentation. I'm talking about using powerful words like therefore, hence, or the proper mathematical symbols that clearly show consequence and flow. Third, you support your claims. Every single decision must be justified with rock-solid evidence. If you boldly claim a line as a tangent to a curve, your supporting evidence is the explicit, written-out calculation showing the discriminant perfectly, undeniably equals 0. You are effectively acting as a master prosecutor, writing a miniature legal brief, proving your case beyond a shadow of a reasonable doubt, using raw algebraic data.
Case file freeze. We are about to enter the most dangerous phase of our investigation, where we reveal the ultimate examiner warnings. But before we reveal this top-band paragraph structure to help you completely clear your upcoming Cambridge sessions, make sure your intelligence feed is totally secure. Take 1 second right now to subscribe to Ace the Exams at Ace the Exams and turn on all those notifications so you never miss our weekly forensic exam masterclasses. Whether you're cracking cases at IGCSE, O-levels, or AS and A-levels, we've got the blueprints you need. All right, perimeter secured. Back to the evidence board.
Section 4. Top Examiner Warnings. Let's cross-examine the biggest pitfalls.
So, we've broken down the model responses, but now we need to look at the dark side. Here they are, the 3 absolute worst counterfeit answer trades that cause analytical logic strings to just immediately collapse under pressure. Mistake number 1. Answers are way too vague and lack specific details. Candidates will literally just write down b squared minus 4ac somewhere on the page without actually stating what it equals or what it legally implies for the equation. Examiners want precise, targeted, undeniable algebraic statements, not vague, conceptual gesturing. Mistake number 2. Failure to check the correct format and presentation. You do all the excruciatingly hard work, you accurately find the range of values, but then you casually write x equals 2 and 5 instead of writing the mathematically proper inequality x is strictly between 2 and 5. That formatting error, it's a fatal procedural breach, and it will cost you. Mistake number 3. Answers completely ignore the specific context of the question. Let's say the question is calculating a physical length and your quadratic yields 2 roots, one negative and one positive. You must explicitly physically reject that negative root on the paper because a physical length literally cannot be negative. Ignoring the context shows the examiner you're just crunching numbers blindly, exactly like Agent Alex, without any real-world critical analysis. Don't fall into these traps.
So the absolutely crucial point is right here on this alert blinking in red. I literally cannot emphasize this enough to you. You must show you're working. It is the single biggest, most tragic vulnerability we see in the field every single testing season. Students will smugly do the discriminant calculations entirely on their calculator and just write down the final inequality on the page. Listen to me, if you make a tiny 1 millimeter typo on that calculator keypad, you get absolutely nothing, 0. The examiner cannot read your mind. But if you write out the initial substitution step, if you clearly show the examiner exactly what A, B, and C values you are using before you touch the calculator, you immediately secure the method marks. Never ever hide your computational evidence. Keep your forensic trail brightly lit, heavily documented, and highly visible on the page.
Section 5. Case closed. Let's wrap up this investigation. Let's completely distill today's grueling forensic session into 3 universal rules to guarantee a 100% case resolution score on your quadratics questions. Rule number 1. The 5-step question scan. You deconstruct, extract, select, execute, and present. Never skip a step, no matter how simple or elementary the question looks on the surface. Rule number 2. The evaluative logic string. Ensure your final answer isn't just some lonely floating number, but a deeply connected, highly justified conclusion that explicitly references the discriminant's core properties. And rule number 3, the contextual proof check. Before you ever drop your pen and move to the next page, look back at the original crime scene, the question prompt itself. Does your final format perfectly match what was asked? Have you formally rejected any mathematically impossible roots? Have you explicitly shown every single step of your working to ruthlessly secure those vital method marks? If you audit your answers with this exact checklist, your structural integrity is going to be flawless.
The case file on quadratics and the discriminant is now officially closed, but listen, your real work in the field is just beginning. Are you ready to actually apply this forensic framework to your next Cambridge Math Pass paper? I want to know exactly who I'm working with here. Drop a comment down below right now sharing exactly which Cambridge subject and level, IGCSE, O-level, AS, or A-level, you are preparing to absolutely conquer next. Make sure you hit subscribe and ring that notification bell so you're briefed for our next masterclass. Keep your evidence structured, aggressively maintain your analytical depth, and we'll see you in the next explainer. Class dismissed.